Programming is so essential to where we are now and then also to the future. Our students need to be able to program. When you get into these jobs, when they get into industry, they should be familiar with it. With the Wolfram language, it's really nice for educators to see how powerful it is and be able to incorporate that into a social studies class, an English class, a math class. It's anywhere and everywhere. And so what we're really trying to do, and what I'm a part of, is to showcase the power of the Wolfram language, but not overwhelm teachers. We want to showcase what's possible, but not limit the creativity that is programming in the Wolfram language. I'm a part of almost every educational initiative that spans K-12. About 3 years ago, we had a meeting with Stephen Wolfram, and he said, you know, I noticed that teachers and students in the high schools are really looking to get into programming, and we should do something with that. Thus began our long trek with the programming lab. How do we make a programming environment it's not too intimidating for a third grader and teachers who have never ever programmed before? How do we make it inviting, but also give them activities, things to try on their own, and not just giving them sort of a blank document to, sink or swim with? We've tweaked the environment, we've created all sorts of fun activities for students to start learning programming. And one of the things that we really focused on for these activities is that we wanted to showcase you can actually use programming to support computational thinking or to support any course. We have lots of activities in the English literature area, in the art and design areas as well. And so with the programming lab, you actually get to see, okay, here's the code that you would use to create your own website, to create your own web form. But for students who have never programmed before, for teachers that are just getting into that area, it's extremely powerful. Look how much I can do with just a little bit of code. We have just had a complete blast with the programming lab, especially in the elementary and middle school areas. They just get totally blown away about some of the smaller things that you can do. It's just anything you could want to do, and showcasing the possibilities is really amazing. Another fantastic resource that we've been working on here at Wolfram is the Elementary Introduction to the Wolfram Language. Now what that is a little bit more structured approach to learning the language rather than the immersive approach from the programming lab. The really nice thing that I think we've done is merge the two learning styles together. And you can find an interactive online version of the Elementary Introduction in the programming lab. So what'll happen is, let's say that you're in a classroom and you want to explore certain types of activities or explorations. And so you can tell your students, okay, here's some that you can try. And maybe everybody's getting stuck on the concept of lists. The Elementary Introduction is built into that platform. You don't need to go someplace else. It's right there at your fingertips. And then there are actually exercises that are there for your students or for even you. An educator, a learner, anyone that's interested in becoming more familiar with the Wolfram language can use it. And so what's really cool about these exercises is that they're actually auto-graded, which is a feature that I've never seen before with coding. I don't need the teacher to be an expert. It does it for me. So if I'm a student and I type in my code, it says check answer, and it'll actually say if it's correct or not. So that's a pretty amazing feature to offload some of the responsibility on the teacher's part. They don't need to grade it. They don't even need to look at it. The programming lab has done that for you. It's one more thing that we've done to try and support the teachers. It's freely available, and like I said, interactive code, interactive grading. It's another resource to be able to become more familiar with the Wolfram language.
Very good morning. Salam Sejahtera. My name is Peter Lim. Once again, thanks very much. I want to extend a warm welcome to you. First of all, I really appreciate those who sign up for this today overview about Wolfram Language and Programming Made Simple. And also some of you came in, they were really early. I like to appreciate it. Now, Rafifa, you were the first one who came in. Yes. We have over 100 people sign up until yesterday. So actually we have full blast of class. But again, we want to be punctual so that we'll be able to end before 12 o'clock. It's 2 hours. Actually, it's not that long. Also, it's not that short. So I want to make sure everyone have really sit back, relax, and enjoy and benefit from this class. It's not just watching a video or entertainment, but we really want to transpile some important knowledge to you. And also, I welcome those who are familiar names to me. I saw names like Janice Wong just now. I think I saw Madam Lim, Madam Lau, also Nick Fasley, Dr. Manisa, I think also there. And I can't really scan through the list, but really, again, I'm really happy to see old faces and new faces. But again, before I get started, I think there are two reasons why people sign up these classes. This workshop, 2 hours, free workshop. And we have 2 more workshops coming up, free one. And next week, we're talking about more details about how to use computation power using a knowledge-based engine by Wolfram. And also, another week will be exactly next Thursday. We'll talk about machine learning using Wolfram programming and make simple. Again, that will be another 2 hours. If you have not signed up, you find this beneficial and helpful, please go ahead. Again, I say there are 2 reasons why people might sign up. First is you are actually curious about when people talk about Wolfram language more and more these days. Maybe your colleagues, your friends, I'm not surprised because Wolfram has more than 5 million users in the world. And Malaysia, we have actually users from almost all colleges, private sectors, and also public universities. So you're here for a first day. If you can, you say, I have not used Wolfram language before. I'm just curious, I want to find out how it could be actually a friend to me and help me in my R&D or learning. Can you type 1 there so I know that today you are new to this? If you are somehow used Wolfram to a certain extent, either as beginner level, intermediate level, or advanced level, can you type 2 on the chat room? So at least I know what kind of audience in terms of new and also that who has experienced before, so that I actually would know how to adjust my pace a little bit. Yeah, so I will not too talk slow or to talk too actually fast. Let me see. Have I switched on? Yes, I have switched on the security for chat. So yes, thank you very much, Mohammed Nasli and Lisa, and say that you're beginner. Some say that you're new. And Janice, yes, definitely you are not new. Yes. Shahira says beginner, and also I see the Gayatri, you say you're beginner. Okay, you all have some basic experience about what Wolfram is. Today again, either you're new or you have not been exposed to this before, certain users, you'll be equally pleasantly surprised. I'll share with you about 4 important core technology offered by Wolfram programming language, which I believe and also deeply believe is very important today for people, not just for computer science background, but especially for people who are applied science, people are engineers. We are not actually trained as a hardcore programmer or coder, but we want to make use of technology, programming, coding, to help us resolve our R&D or our learning problems. Yeah, that's why we're here. These are 5 major core technologies that become very important cornerstone for advanced scripting programming language today. Again, for those who are first time here, I introduce myself, Peter Lin. I've been in the industry for 25 years. As long as I can remember, I almost devoted my entire lifetime yes, in the industrial planning, optimization, operation research, and also expert in machine learning and artificial intelligence. Some of you attended my class before as a Wolfram trainer. Yes, our company is a certified Wolfram trainer. And also we are certified HRD Corp, means Human Resource Corporation Malaysia. We are certified trainer for various classes. Now, enough introduction. I believe that you have received activation code, either is the 1-year activation key or 30 days activation key from my facilitator. Desmond. Yeah. So if you have this key available, you could actually activate your key. Actually, you can actually open up the application. But again, open application means that you will be able to have a chance to tap along with some of the practice. But today, that again, some of you might ask, hey, Peter, Desmond, could I have the things, the material we are sharing? Yes, but not now. After a class, stay back. We will send this material in a chat room. So if you come for the class, then you get the material free. Yeah. This whole material will be very useful for learning and sharing. If you want to share with your classmate, colleague, there'll be a wonderful actually presentation slide. You can recycle. Yeah, it's free for you to download after the class. But if you say, hey, I have received the activation code for my application called Wolfram Language, but I actually using my mobile phone right now. I'm driving. If you're driving, please drive carefully. I like you pay attention. You're on the road, not on the screen. I say just in case, or just in case you use small device, you might not be able to actually open up the application like what I'm doing right now. So I can introduce you actually by this link. I'll pass this link to the chat room. You can click open this link. You ask you to do a little registration, but it's fine. After you've done a little registration, a quick one is taking less than 1 minute. It will allow you to open up a cloud-based sandbox. Sandbox means that it's actually meant for training. It's online cloud version application. It functions the same as the desktop version we're sharing right now. So if you say, hey, Peter, you just told me right now, when you start talking, I actually busy working on the sandbox, I might miss something. Like I say, not worry. Yes, the next few slides of screen, like I say, I start introducing one of the 5 core technologies, one by one, for the next few sessions. So beginning of first sessions, first 10 minutes, you basically just sit back and relax. And you have the good surprise overview what is happening out there in the technology offered by Wolfram Research based in US Champaign. Yeah. So you do not have to be concerned while we actually try to open up sandbox at the same time. Say, hey, I could be missing something important. Not worry, not worry. Okay, like I say, just listen for the first 10 minutes. It's a quick overview. It's pleasantly surprised at what is happening out there in the world right now. Okay, now, when you talk about Wolfram Mathematica, sometimes people actually more familiar with the term Mathematica because this package been around in market for 35 years. In the early time that is seriously used by many mathematicians. So that's why Stephen Wolfram, the founder, also the inventor for this system, called it Mathematica. I believe so. Yeah. So a lot of people will have misconception. Oh, Mathematica is meant for people who want to do math. Just like SPSS is meant for to do statistics and apply statistics. Or not like that. Yeah. The naming just a naming. Yeah. So this day people start calling Wolfram language because people find actually it's more like advanced scripting programming language rather than just something called Mathematica for math people. Not really. Yeah, it's so easy, used across all disciplines and domains. People coming from non-technical backgrounds appreciate it the most. So Wolfram Mathematica is a world's first computer algebra system. We call CAT. Yeah, you probably heard that before, but it's not that important this day because most of the systems these days actually follow the invention of Stephen Wolfram. When it calls computer algebra system means that you can actually type in the symbol as what you see in the textbook. Yeah, whatever you see in the textbook, then in the past, if you those born in 70s, 80s, still can remember this computer screen with a green color or white color. Yeah, so you can just type ABC, but other symbol can't really do. But as early at the time, Wolfram can start processing symbol already. So we call it computer algebra system. So this little bit knowledge for the sake of history. Yeah, but this day, this thing is common. Yeah, because computers so advanced, it is common. Yes, it's almost all systems would suppose solve with engineering or math and scientific problems. They have to be a CAT system. Yeah. So what Wolfram or Wolfram Mathematica is all about? Yes, this package is called symbolic computations. What does mean symbolic? You probably have heard about numeric computation. What does mean symbolic? Yeah, I do not want to assume that actually you know this, but later on let's show you some example. That means, oh, This is what means symbolic. Yeah, not all actually programming package can do symbolic. Yeah, that well. And it's in widespread in science, engineering, math, and computing. And it's an original flagship. Now, when I say original flagship means that a lot of the technology evolved around Mathematica for the past 25 years. And now it actually evolved into not just desktop version as what I'm sharing with you now right now. Actually, I have online version come out. I think that's why the sandbox is the one actually you use it for online version we call cloud version. You can actually make use of Wolfram Cloud, or you can also set up private cloud. So some of you are seriously actually want to deploy your own solution for faster speed. You can always set up private cloud using Wolfram technologies. Make that way. So now, when talk about Wolfram language, it's a programming language for general computation. So because it need to be actually used for people for doing computation, it has to be easy. Because like for instance, it's not that easy already to handle math engineering problems, right? If someone asks you to be, oh, let's go program a C++, or Python. Yes, Python getting very popular, but honestly speaking, a lot of us will have a fear. We want to learn something new, even though Python is not that difficult also, but we are busy enough. If you want to pick up something like programmer does, then maybe there's some alternative we can look around. Yeah, there are some other things like Wolfram Alpha, Wolfram Development Platform. Now, to you, this name, you say, I don't really care. It's fine. Yeah, I might not care as well, because important thing is, what could it do for me? What could it do for me? But before we say what it could do for me, then I share with you what it has done for others. Now, this is not something I put in for marketing purpose, but I just want to put in there to instill some confidence that you are not the one who exposed something entirely new to the market, but it's something that a lot of university, top 200 university, entire top 200 university in the world, they will have different sizes of Wolfram mathematical technologies one way or another. And down here is a series of university in Malaysia. We are not talking about the world, but these are names are familiar to you. Some of them are having like entire campus license for everyone, from lecturer to student. They can run in a cloud, they can run in on actually the mobile phone, can run on desktop. Some of them have lab license, 20, 30, 50, share among different faculty depending on needs. And we have a lot of individual researchers actually using their own individual license here and there. So these you can easily run into people that are actually using Wolfram and benefited from technology. So this is something to let you know that before we know what it could do for me, then at least I know that it has been successfully actually benefited to a lot of people in the community out there. So whenever we want to look for help, yeah, there are always help available. Now, and again, I believe that some of you are Python users. If you're a Python user, can type 3 in the chat room. So I know some of you are actually either you're beginners or you're advanced. Yes, Ruben say that you are one of Python programmer. Wonderful. Python, I do not have to elaborate too much. It's a very vibrant community. Yes, being ever growing, one of the fastest growing actually programming community in the world. And you should actually pick up some Python. But you say, no, I'm not programmer. It's just I want to stick with one easiest one. Yes, I say that could be alternative. Now, people might ask, if I know Python already, why today I care to try to learn a programming language? There are tens, hundreds of programming language out there for different purposes, for web-oriented programming, to desktop application, to some programming is good for development, some programming is good for analysis purpose. There are various reasons people use Python, or also another program you're familiar with, MATLAB. So these are two links I give to you. You can actually have a very objective comparison. Why sometimes people want to actually able to master at least 2 or 3 different technologies? Yes, because different organizations, different companies go to, people these days they are concerned in what's a faster tool, the most economic one, efficient one, help me achieve objective I have. So certain company might opt for Python, certain company for opt for R, open source, certain company opt for Mathematica Wolfram. Wolfram Mathematica is actually stand between open source and proprietary software. So how come you say proprietary software, it could be the same time open source? Open source, the main feature is free, yeah? Second feature is people can contribute. Yeah, and you can contribute communities. Yeah. Third feature is and they have very vibrant community to support. And Wolfram, in a way, even it's proprietary, you have to pay some for some of the modules. But certain modules are made free. Now, which modules are made free? I will not explain now in details until you find out, oh, why it's helpful to us. And also, Wolfram now open up a lot of source code. In the past, the source code are locked up, but these days open up, so you can actually contribute it, you can review it. In the past, that people would, like, for instance, pure math, they might not like it. Say, hey, this is like black box. You give me a solution, but pure math people, I want to see your algorithm. Yes, these are all made available these days. If you are more actually in the area of numeric computation, MATLAB, of course, stands a very good status in the market, particularly in the area of simulation for engineering. Yeah, if you want, for instance, people want to do simulation for engineering, and MATLAB is well known in the market. Of course, you say, could Wolfram do that? Yes, it could, only by compared to the user community. Yes, MATLAB is stronger in the area. Yes, you say, hey, Peter, I thought you represent Wolfram. Why I say like that? Like I say, here I will expose all the good and bad things objectively, so that we as R&D community, we can benefit. Yeah, so then you can see in what kind of situation you use this and that. Now, these are quick introduction about what's happening in past 35 years. Now, technology actually changed a lot. Yes, this is actually in past 35 years, Wolfram averagely every 2 or 3 years. The longest gap I've ever seen is about 4 years. They release a major upgrade. But thanks to technology, and this major upgrade, 11, the version 13, almost happened in the past 5 years. So we see almost 1.5 years. Wolfram will have a major release of version. And the people sometimes say, why do I care about upgrade? If the solution work for me, I don't mind stay about old version. Yes, true. Yeah, but if you're in an R&D and teachings, right, you always want to see if their latest actually technology help me to ease my load. That's the reason Wolfram spend huge amount of actually efforts as a proprietary software developer. You will see the latest version 13 to release this month. They added in additional nearly 1,000 new functions. Yeah, if you say 5,000 functions is crazy enough, they added in this new release now 1,000 functions. You say, why do I care? Is it 1,000 function? I might not use it. It's true enough. Yeah, true enough. But if you're in the R&D area, you could be pleasantly surprised. Some of the things previously not available now is actually added into the family 6,000 functions, meaning that no matter what kind of perspective you're coming from, you're teaching math, you're teaching engineering, physics, chemistry, things like that, you'll find more and more available actually resources built in for you to make your learning and R&D much easier. And again, I'll share with you later. In compared to you alone develop some of the technology later, why we actually want to opt to some of the function that make it available. Now, there are 5 major actually pieces of flexion or core flexion. I'd like to share with you how it will benefit us. Now, the first flexion here, I would like to share with you here is about linguistic understanding. These are those actually join us before. This linguistic actually is not something that you do not know, because this is something that very popular in the market about Wolfram. Most people actually came to know Wolfram language by this linguistic understanding as early as 6-7 years ago. It became a major discussion in the technical community. There are some other things that Wolfram language, curated knowledge base, integrated algorithm base, computational notebooks. I'll explain one by one in the coming slots. Yeah. So, and some of the thing is you use for R&D, education, data science, enterprise application, software development. Yes, it's important. You say, hey, I use for R&D. Eventually, I want to develop it. Could it possible? Yes, you have to. And this one is popularly used called content development and publications. You see, the screen that I share with you is not Microsoft PowerPoint. It's entire interface offered by Wolfram Language. I use it for computation, also use it for sharing as presentation. Also, I can use it for publication. What if you as students, how could it help you to actually able to grasp what a textbook has actually transpired to you through this lively integration of technologies on your desktop? Yeah, I'll share with you later. Now, let's see the first thing here, linguistic understanding. What is all about this? Why we pride it so much in linguistic operation. Later on, this is something that I would like to play with the notebook interface open, either it's desktop version or cloud version. For instance, here, in this expert level answers, right? When you say this linguistic understanding, we have actually this Wolfram algorithm called knowledge base and AI technology built in. It gives you an expert level answer. When I say what I mean expert level answer, this all the thing here we embed with link. Yeah. If I move over the mouse, this link actually points you as another cloud engine called Wolfram Alpha, but I do not actually have to do that. Ask you to go to the website right now. But later on, if you actually click on this link after download this particular file from us, you may actually surprised to see how easily you can solve this thing. Of course, you say, oh, this is like primary school problem, but let's start easy first. Let me share another screen. Screen 1. Now, you see this screen coming up where you say 3x plus 4. Yeah, it brings you to this website. You say, Peter, how can I bring website? This is a reason I share with you. Yeah, a lot of applications actually come free. Yeah, that's why Wolfram is heading directions like partially open source. In order to actually solve you a problem, this is an input. It shows you a block, okay? It shows you alternate term. It shows you solutions. Yeah, it's almost like if you want a step-by-step solutions, yes, you can click on that. Of course, step-by-step solution is not available for free version. Later on, I share with you why sometimes we need to pay a little bit prescription to give a step-by-step solution, especially you're teaching or your student, you have a better understanding. Now, for instance, this little simple linear algebra. So if you come here, you have x, y, two term one solve, and say, okay, this is solution x, y, and where's the solution is. Just this intersection here, the point pointing up where this is a solution, x is this much and y is this much. And we have alternate way of representing it. Yeah, y is like this in terms of y, or in terms of x, you can do that as well. Then eventually you can download a page. But now this page is free. But some other thing you say, oh, Peter, of course, if this is the technical package you're talking about, you can solve all this kind of thing. For instance, I want to solve derivative, integration, or the calculus related problem, or plot sine curve, all those are things free. Yeah. So similarly, you say, hey, how about discrete math? If I expand this thing, discrete math, if I want to determine some logical computation, like injective, subjective, bijective, how do I explain the class? Yes, you could actually have this thing explained in this discrete math textbook. Yeah, but if you want to student more interactive play with that, you simply type something like this, determining injective, subjective, bijective. How would it come out? Yeah, for instance, if I say, if I type something called theory of plotting, proportional logic, probabilities, what would it come out? Of course, you say, if I type in something in my Google, you give you actually output, yes, everything. But if you're typing like this, right, little things like, for instance, is this thing bijective for x less than 2? Yes, the x cubed plus x divided x minus 2 is a bijective for x2. You say, hey, what does it mean? Yes, if you in a textbook, you already explained a bit about proportional logic in discrete math, and you do not ask a student to simply go Google search for all kinds of different answers, but you ask them to go to Wolfram Alpha, all of them looking at the same things or explanation in a very systematic way and a very technical way related to how things textbook will explain it. So it immediately give a result. You say, yes, why in terms of x is this whole thing is bijective from a specific domain that belong to R. Yes, this whole thing that actually you can explain very well step by step. Now, enough of this. When I say linguistic knowledge, right? This is what it means. If you say, hey, Peter, this is not linguistic enough, as if you're typing in the mathematics equation and a logical equation. Yes, it's true enough, but you see, actually, it does not follow our actually scientific term per se. What if I want to know something about earthquakes in Indonesia in August 2018? Yeah, the reason I put this thing is when we talk about earthquake in Indonesia in August 2018, right, we can key something a rainfall level in Malaysia in December 2021, which just causes a century major flood. Yeah, things like when we key something like that, what would it show up? Yeah, in Indonesia 2018 had major series of earthquake. We want to show the students ourselves that how serious 2018. Yeah, 2018. So this is show everything. This earthquake in a record scale in magnitudes in 2018, starting from January to December. Similarly, it said, hey, Peter, in Malaysia, where rainfall actually they claim between the 2 days of rain is equivalent to a whole year of rain level in Malaysia. Did that happen before? Did we have serious actually rainfall before? Yes, if you live in Johor, you probably still remember 2008. Malaysia, at the same time in December, is a major flood. Yeah, could this statistic be show up in the 2008? The rainfall is actually lesser than what we had in 2021 December. You could be surprised. Hey, we have actually more rainfall before, but we do not have such a disastrous outcome. It could be other reason. So you see, it show up the time series actual representation of data. When you're able to show you the time series based representation of data, you can do a lot of analysis already. Yeah, it's not doesn't just show you the raw data per se, but show you the time series data. It's already time serialized for you. Okay, let's come back. In other questions that you ask, income Malaysia's, income China. If I simply put like that, what will show up? I can put it income Malaysia, income China. This one is division. When put division means that actually you can show the fraction of these two countries. Yeah. In this case, it shows that in Malaysia, gross national income divided by China, that means that our Malaysia currently, based on 2020 estimate, we only 2% based on the overall gross national income of China. So this is something that quick statistic we can get. Also, it shows us that our comparison and what will be the difference between two countries. Yeah, we know that China have a huge number of national population, so that the gross incomes will be actually more than us, but necessarily. But you see over the year in 2018, 90, 2000 up to 1990s, right? This entire overall gross national income, Malaysia's developed compared to China. That means that China is way actually advancing and actually compared to us. Then they are being actually advancing quite likely. Its average income per capita has increased a lot. So that's why it shows this kind of thing. So this kind of interesting statistic or representation difference visualization, you can explain very well in the class. Now, how far is Mecca? You say, oh, this thing, why do we need to know? But if today teaching geography, we want the system to show up actually different way. Actually, now when I say different way means, yeah. Now this is something interesting. How far is Mecca? Now, when you say something how far away, right? You not just measure in distance in terms of kilometers, miles. You also can actually measure is nautical miles. Hey, what's nautical miles? That means is the total miles sea travel usually measures. If we travel by aircraft and by sound, by light in fiber, yeah, 33 minutes second, light in vacuum, yes. All those things actually is showing you in a scientific breakdown. Yeah, like this. There are more information, but this is free version, so it will show you that partially. Yeah. So in this case, I say if we go from here to here, is about 1/6 of Earth circumference. See, there's a lot of things actually explain what the Earth circumference is 1/6 from Malaysia to Mecca. And again, you say, what's the current premium of Malaysia? Yeah. Some other things are interesting. You ask that, for instance, if I put in chemical reaction, would it actually solve it for me? Would it balance for me? I want to display some molecule things. I want actually give me a comparing coffee in a cup of coffee and tea. Could you give me a comparison? Yes, it will. So this case actually gives us a lot of natural language and natural language understanding. So if we put in current premium Malaysia, right? Yes, of course, it knows who our prime minister is, and also he knows who is our prime minister and who was our prime minister, and say how long they are actually in power. Yes, and for all the previous premier. So these are actually we are not actually teaching history class per se, but this one could be used in many ways. It try to explain things in numbers. So a lot of time that we want to come up with certain facts and figures, you can go up to Google, look at Wikipedia, it give you all kind of informations about something. But a lot of things can be represented better in data, in figure. That's why we switch to something called Wolfram Alpha. That's why it has something to do with scientific representation. Sometimes it's very important compared to you give a whole paragraph of descriptions. So this is called linguistic understanding. Okay, let's try it out. Let's try it out. What do we want to try it about? For instance, here, if you actually open up the sandbox, the sandbox looks like this. Yeah, let me show it with you. This is the sandbox that you have opened up. Let me see, not this one. Okay, let me click on the sandbox again. Okay, the sandbox link I put in the chat room already. You can click on the chat room one, you open up the sandbox. You will have something like that. So in the sandbox, if you see this screen coming up, you can actually go and type it. Same thing. And if you have desktop version open up, now you can try. Now, in order to try out this natural language understanding features, this is certain plus sign on left hand side. If you click on this plus sign here, there are a few things here you can click about. This first thing is called free form input. Second one called Wolfram Alpha QE. Yeah, input, you could select free form input, you give you this thing an equal sign. Yeah, so for instance, you say something via natural language. I say, I love you. You type, I love you. Yeah, you say, hey, Peter, what does it have to do with scientific computation? I just want to let you know. Things not necessarily come out with facts and figures only. The system has AI built in. So in order to run this thing, right, if you're using cloud version, you only have to click evaluation like this. You click eval self. Yeah. So the system start running. You say, okay, how nice, be assured the feeling is mutual. Yeah. And again, if you click on plus sign again, you say now I select Wolfram Alpha QE. And now you say that how far is moon from Earth? Yeah. Now you can type it evaluate, or second way is if we are actually exposed to mathematical, you know, for it to run, it's not click enter. You click enter, right? The system thought, oh, you want to go next line. You see, if I click enter, the system thought I'm going heading next line only. You hit shift enter. In your keyboard, you have two keys. You shift, hold the shift key and hit enter. That system know actually you try to do evaluation. Yeah, like that. So now this is sandbox version. If I come back to this version here, same thing. This is a linguistic understanding from alpha. You have equal sign. If you want to actually use your own equal sign here, now, in order for me to show you computation, I can do computation here. For instance, I love you. Hit shift enter. You see there's something like input sign coming up. The system start running it and they try to understand that what I'm trying to do. So if you hit shift enter or evaluate, same thing, this is desktop version, it will give you an output like in what you see in the Wolfram Cloud. Now, because I'm running for computation for the first time, the system is waking up the kernel. Kernel means actually there's certain backend computation that will actually perform all the calculation. So it means that actually you will not actually require this front-end interface as long as you know how to connect the kernel. The system actually can perform a lot of computation invisibly in the background. So same thing here. If I want to put here, I say, hey, I want to solve 2x. Now, you can type anything, 2x. Now, 2x square minus 4. Yeah, go to 0. I shift enter. Now, I simply type any English. I do not have to be like capital letter or lowercase. I simply type any, as long as put solve. Yeah, something like that. The system know I'm trying to solve this simple equation here. Yeah, just like that. Now, down here, this is like Wolfram Alpha. Again, you say, Wolfram Alpha, how to do that? You can, same thing, there a plus sign here on the top left corners, click on Wolfram Alpha, yeah, entry, or easiest way is in this case, yeah, you hit equal sign in a keyboard 2 times, become like that. Yeah, hit your keyboard equal sign 2 times like that. So then you say, if I say, I take my morning with durian and bread. Yeah, funny lah, people don't eat like this lah. I'm not sure. At least I don't eat like this durian and bread. I want to know what will be the carry line. Yeah, I hit durian and bread. The system seems to understand a lot of things. Yeah, a lot seem to understand. It say, okay, if you want to eat durian like this, right, and bread, right, this is what happened. Yeah, this is what happened. In terms of calorie, it will assume you eat durian 140 grams and bread 50 grams. This one is like that. Yeah. Then if you say, oh, it knows so much of this, how about some of the technical things? You can ask the system to do integration. If you say, I want to do integrations, I put integrate 4 power of 4x power of, let me see where's, yeah, power of 4, yeah, okay, minus 4, yes, I put log, yeah, make it slightly more complex here. Now, I simply type something. See, I do not actually follow any so-called syntax. I simply type in as my own plain English. The system immediately understand. This is what I'm trying to do. You say, this is log itself is a natural logarithm. Yeah. So you say, oh, in fact, you will try to do something like this. So system show me a series of solutions here. For instance, here, down here, you say, if you want to do this thing, right? Yeah, this is solution. But I say, how do you get this? You see, right-hand side here, you have something called step-by-step solution. Yeah. Now, I know you probably have not typed this thing, but I'll let you have time to try it out. In the system can show a step-by-step solution in a desktop version, but not in a cloud version. If you're using cloud version, probably will not show up. Yeah. But I'm using this now desktop version, so it's available here. This whole thing still computing. It's showing me a lot of things that I might be interested in. Say, show me step-by-step solution. How to get this? I click the right-hand side here. It shows it to me, oh, this is how I do it step-by-step integration. Yeah. So in this case, as a student, I'll compare my result. I can understand better how the integration of this particular equation is achieved. And also as a teacher, also can actually explain better, maybe follow this logic. I show in the class one time, oh, this is how it works. Now, if you still have questions, go back, try it out your own. Which part you don't understand, just speak with me. In this case, you make your whole class more conducive. And again, important thing is, you want the student able to visualize. If I today, I do the whole integration, how the actually plotting looks like. You see this plotting X and Y immediately coming out. It not just come out like that. I can actually toggle it accordingly. Down here, I actually have something toggle. If I change some of my value of accordingly, and how does it look like? Yeah, I can change the range and zoom in and zoom out to certain part of the display of the solutions. So there are some other things like alternate form integration. Yes, some people might show it the integration in different form. Say, hey, I come up with different result. These are 3 different actual results come out accordingly. Yeah, it's displayed in different forms. Some are expanded with different terms. This look like, yeah. So it's like several actually way you can compare it. So the things actually you can actually, for instance, there's some other thing. Let's say I put like this, like say human brain. I put human brain. If I'm teaching biology, like put human brain. Again, imagine you go Google it. Human have brain or not? Yeah, true. It's a human have brain. So sometimes I try and error. I say brain, just brain. So it say human brain. It say human got brain or not? So now, so I change to something else. Say just brain. Yeah. So the system will give me the different result. I'll say brain is human. Then if it's human, then how the brain looks like? Yeah. What does mean how the brain looks like? You say, oh, this is one of the organ. Yeah. And this is how it looks like. Yes. And the brain actually consists of how many parts? Yeah. You say, oh, these actually have different groups. Yeah. Caudal cavity, brainstem, midbrain, hindbrain, forebrain, things like that. And this is how location was located. And if you're teaching biology, right, you say, oh, typically this is how a human average looks like. If you ever study time and motions, right, before those in the industry, a lot of human standard actually, you have to refer to a textbook one or human standard arm length, how long? Because you need to design certain working environment. You want to design a car for Asian, right? You can so simply assume, the seat should be like this or should be like that. The car seat could be too high or too low. Yeah, you still have to refer to some human standard. So Wolfram will have a lot of human standard built in. Like this averagely human brain, 1.4 kg, yeah, volume 1.3 liter, things like that. There's a lot of the actually standard you can refer to, or it is all built in. So for teaching and learning is wonderful. Now, I'll go to next slide, but I'll pause it for 5 minutes. I'll open up this screen. I'll let you actually type it accordingly. Now I give you 10 minutes. Now it's 10:44. Yeah, we about finished the first portion. So I'd like you to try it out. Either you're using this desktop version. Yeah, you can start typing in. Typo error, no issue. Typo error, it will not give you error. Just simply say, I don't understand. You can go to your cloud version, same thing. Type according this question on my screen. You can choose any question you like. You try it out. Whether this thing is actually interesting or not. You can try it out. For instance, just now I already try one, like this one below, right? I say, hey, I'm interested in knowing how far is moon from Earth. Now, those actually experience the major flood as a victim like me. I also want the answer here. Yeah, you can try water level in Klang. Yeah, see, what's the water level like? You don't look at the forecast, the official forecast in somewhere in news, in a website whatsoever. You simply type in this thing. You say, hey, I want to know what's water level. Can. Or be elevation at Klang. This is where I live. Because I'm afraid sea level can go up. Then you give it actually result, if tsunami come, will Klang be actually this what should I use a term? I don't want to use better. I almost want to use hapus. Could it be actually covered by tsunami? You give you some scenario. So try a few things here. Rain and Klang or population and Klang or the hometown. You can put your hometown. If you live for, let's say you look at Klang, you put Klang, you put a Georgetown, you put Georgetown, see whether the system understands. Wolfram understand nearly about 140 cities in Malaysia, about 200 over city in Malaysia. So you can try out different city name, or you can run this thing. I give you 10 minutes. Now 10:46, come back 10:56. Yeah, okay. If you have questions, I can type on the chat room. We'll be happy to answer. Okay. Okay, we're getting ready to come back. We only have 30 more seconds. Now, I hope you have fun. Next Tuesday, our facilitator Desmond will give you more detailed hands-on how to play with knowledge base, not just with Wolfram Alpha, but also how to actually make it to be really interactive as something like CDF. What does mean CDF? No, today we won't talk about this. There are more details next Tuesday, so you come back next Tuesday at 10 o'clock if you want to really know how to further be benefited from technology like that. Okay. For instance, you see the last one. If you want to see how dogs see things, yeah, put dog vision on a cat picture here. You really the system will show up how actually dogs look at things. You always say that dogs look at things different from human. That's quite true. Yeah. Now let's look at second important features here. Second important core technologies of Wolfram. It's called computational notebooks. Yeah, when I say notebooks, that does not refer to your laptop. It means that the interface are open up. So these notebooks, right, this term now being adapted by other technology inventors, especially in software developer, follow what the Wolfram term. In the previously, when I say notebook 10 years ago, not too many people understand. But this day, you find that like Jupyter, you're using one of Python user, you might use Jupyter interface. They call notebook also. So this term actually is quite pioneer or invented by Wolfram. Yeah. But you say computational notebooks means what? That means whatever I'm using right now, I'm not just sure using it for computing reason. But you see here, this entire interface, yeah, as an ordinary daily users, I can use it for many, many things. Like as I mentioned, when it comes to version 13, which is launched this month, they have nearly about 7,000 built-in actually functions already. Why is so important to keep on building function, which I'll come to explain to you in a short while, why today, when it comes to advanced scripting programming language like Wolfram, it becomes very core importance benefit to many of us. It's all carefully integrated, so it works perfectly together. Now, when inside here, this is entire actually help file available. So I no need to explain one by one in two details. Say, Peter, this all colorful icon looks nice, but how does it actually help me? So if we go to help file here, the first one called Wolfram documentation. Today, I think important part is we want to enjoy free software, yes, but sometimes free software is all depends on the developer how they actually do documentation accordingly. So some documentation might be documented in a way everyone could understand easily. Some might not be that easily understood. But Wolfram has a standard way of actually categorizing their documentation. So if you open up Wolfram documentation, you don't need to open up. This whole thing is actually step-by-step links, carefully categorized. So either for engineering computation, yeah, dealing with time-related computation, time series, things like that, or something deal with the geographic data. You say, hey, I'm not teaching geography. Why care about geographic data? This day, when come Industrial Revolution 4.0, everything is always do time, space, location. Yeah, you need to know what time it is. You know how big space is. You know where you are. So this Industrial 4.0 actually integrate all those things real time. Yeah, so you're able to give you strategic result and solution based on time, space, and location. So that's why geographic data this day is very important as part of the computation power. So you go down here, also give you other things like workflow. You say not just actually break down according to core technologies, it break down to workflow, meaning that if you're interested in working on a notebook, it shows step by step how to create actually deployable notebooks. If you're interested in creating documents and presentations, that means, for instance, you want to convert, it shows you how to convert into LaTeX for publication. If you want to organize it, creating some or do some interesting interface for interactive interface, how do you do that? Yeah, and if you want to work with data from basic data cleaning all the way to data import from various systems and integration and output, how do we do that? You give an entire workflow. So same thing that you give other things like cloud, set up administration, so on and so forth. You give it entire things here, and also additional resources like training resource and the fast introduction. You give a series of videos all free that you can watch and learn based on own step. So this is computation notebook. So let's see what computation notebook has to offer. If you look at this thing, is like super computer notebooks. It have very convenient integration. It's not like 10 years ago, oh, I want to integrate on, or then you have to install this, install that, and we do a lot of integration here and there. No more this day. Wolfram now actually have a lot of actually something like a dialog box. Yeah, you just actually, what I have to do is you key in a Python code, key in a Node.js code, and key in some whatever code directly, the system actually will run it right away. It's not like in the past that you have to do a lot of configurations to make things happen. Wolfram trying to take this thing away from the hand of a niche domain expert into ordinary users like you and I. So for instance here, let me switch this thing from presentation node to working node. If you see what I'm doing right now, my screen environment right now is slideshow. Now I switch to working. So now the system now show me a slide by slide quite clearly. But one important thing here is when I switch to working nodes, actually it allows me to do more control. Now in this case here, I click on here, this one line coming up, horizontal line. I click on this plus sign. It showed me like Wolfram language input, free-form input, Wolfram alpha query input, external language input, yeah, plain text, other style of text. If I click on external language input, then it has special dialog box to show up. This special dialog box will ask me, oh, by default it's Python. If I say I'm not using Python, I'm using Julia, I'm using Octet, using Java, Ruby, Node.js, I'm using R. What you have to do is copy and paste here. The system run inside Wolfram environment, and you can even by additional 1-2 lines, you can exchange actually output and input seamlessly, yeah, inside Wolfram. Yeah, this is how wonderful it is. You say, hey, I've developed something already in Python. You no need to redevelop again and do a translation to from just copy and paste the entire Python file inside, or you can actually run external Python file by calling external file Python and run and get a result into Wolfram for post-processing or pre-processing. Yeah, this is how wonderful it is. Now let me switch back to presentation slideshow. Now, this is second important core technology. So if you look at this thing, I'll leave this part more to Desmond next week. So as let you know is when it comes to visualization, 2D and 3D or data visualization, it's more than you ever actually imagine that they are available. Yeah. So it is all kind of scientific representations. Yes, all available here from the very basic 2D and 3Ds and everything ever needs. More than you need, yeah. Usually be pleasantly surprised, and all the statistic distribution, it has more than R can offer to you. Yeah, R being used by statisticians in the community. It's a very wonderful package, but as a proprietary software, it's always trying to outbid other open source to keep in the business. So that's why you always find, hey, whatever I can do in R, definitely you can find the same thing from, if not more. Yeah. So same thing here, important when I say it's super computation notebook means a lot of things actually, this is something that Desmond probably will show you next week, how you actually able to create an interface like this on the fly. So if you're able to actually deploy many solutions like that, very lively as a lively content, as a presentation, as also a publication. So your publication will not something like PDF anymore. It could become something very actually dynamic. You can put in the website and let the user really understand what you're trying to explain the concept. So this is called super actually computational notebook. So the computational notebook also you can actually convert it into a live report carried by salesperson at the field, or engineer or scientific people at the field to show different animations or simulation analysis without actually seeing your codes. Yeah, this is wonderful thing. Become actually application on its own. Of course, these days people more concerned about cloud. Yeah, so if you people don't really say, I don't want to install my own application on laptop anymore. As long as there's internet connectivity, can I use cloud? Yes, you can easily convert cloud. But now, let's start actually doing some exercise. Yeah. So important thing, if you exercise a little bit, you can overcome the fear. So now, let me try first. Yeah. for instance, here, I want to actually create some user interactive elements backed by these super computational notebooks. So this notebook I'm showing as presentation, also something come to life. So if I want to plot this thing, I want to plot sine. Sine actually, sine x is actually range from 0 pi radian to 10 pi radian. So if I plot, it's nothing impressive. It's kind of like that. But now, in the class, I simply tell them, when I say pi radian, from 0 to 10 pi radian, what does it mean? In pi radian. If I want to convert not just pi radian, I want to make the degree range from 0 to 360 degrees, so on and so forth. How does it go on? Here you can also convert to degree also instead of the default radian. So now, but let's try this. Let's put aside this one first. Now, if I want to plot 3D, for sine x and cos y. Now, I'd like you to try right now. Either you're using a sandbox or the notebook right now. As you type, you do it right or wrong, no worry. At least you try. So I'll try show you how I try. I want to plot 3D. This is how usually we do it. Then you find so easy. So for instance, right now, I'm not using Wolfram Alpha query, so you cannot use a previous method, which is natural language understanding approach, but I need to use the proper syntax right now because I don't want to use that thing to interpret for me. I want to very clearly say that my x radian range from what and what, y radian range from what to what. So in this case, I put the proper syntax. In proper syntax, and Wolfram, all the functions follow our mathematical function. When you see function here is a square bracket x, sine x. I say I want sine x and cos x. When you type, the system actually give you guidance. You say, are you trying to type cos or cos? You want to do cos integral or cosine distant? So everything with something to do with COS come out. I said, no, I want this one. If you say, I'm not sure how to fill out cos, you can click on this information The system actually give you actually documentation, tell that how this cos will work. It give you example, it give you tutorial, it gives you all the advanced cases, and also tell you that some of the reference can refer to like arc cos and also degree and things like that, something related to this function. So this is one of the 6,000 functions. So then I say, okay, sine x and cos y, like this. So the next thing here, because if you put like this already, right? You say, now I want to plot 3D. So I just move this thing down. I say, now I'm going to plot. You see, I type plot, right? So how do I know this 3D? So I roughly know something 3D lah, plot 3D. So I put like this. The system say, okay, now I'm going to have this plot 3D as function. So everything a function have to start with open square bracket and close square bracket. So I put down here. So I know at least I have plot 3D, sine x and cos y. So now I need to define the radian of x and y. So next thing is I put a comma. So I tell the system, okay, now the radian, right? When I plot 3D, I have this first actually domain like this. I need to define the range for x. So the first one here, x, second one is here, y. Now I say x now will follow is what, minus 10 to 10. Put the range, and y is radian is minus 5 to 5. So this is like simple like that. You put in sine and cos first, then you put in plot 3D and put the proper comma sign with the range. So that the system will give you actually answer right away, something like that. That's simple like that. So you can try. Now you try. I give you 1 minute, you try it out. Okay, so I'll let you try. When the music stops, then you stop lah. Okay, 1 minute is up. Yeah, thanks for suggestions. Yes. And say, could we actually paste that equations there? Yes, Magdalene. Yes, here you go. So if you say, hey, I find that I'm not confident with that with the keyboard, you can go to that room and copy it and paste it. Also, some of you are asking, hey, do we have recorder session? Desmond will arrange with you. Yeah, definitely. We do not actually live stream it to YouTube or Facebook for now. We just save it. So later on, we do some conversion. So I think Desmond will be happy to arrange with some of you really want to listen to that entire this 2-hour course again, no problem. And also I see Nasli was asking, you interested in performing transfer function, but can work, no issue. You later on you can WhatsApp me about what you want to achieve. I can actually spend time with you about what you want to achieve so that we can carry on the class. Now, you have any more questions, you are most welcome because we are here to help you just realize that how you could be benefited by some of the available technologies out there. So even though you ask questions until we cannot answer better, so I can also go escalate the questions back to the necessary expert who might know the proper answer. Yeah. Now, how about we plot 3D? When we actually add in some a more variable inside, let's say we have add in a determinant called t. Yeah, t also range from -20 to 20. But we want to make this thing to be the user actually manipulate, user interactive. How to do that? So in order to create user interactive, actually it's not that simple. But Wolfram make it very simple. Let's try it again. Now, in this case here, I have sine again. You see, when I type it xt, I have one additional here determinant, yeah, xt. And again, I have cos, yeah, cos y, yeah, like that. Now, in Wolfram, right, if you actually make this to be a product, right, you put a space here, the system knows it's a product. You don't need to be like put a dot or x for the system to say, hey, I have actually product x and sine and cosine. No need. You put a space there, the system knows this is actually intended to do a multiplication. So now, if I put like that already, next thing I say, hey, I want to previously plot 3D. Okay, I just plot 3D, same approach. When you type it, right, the system show as black color. It means that it recognizes this is one of the 6,000 functions built in the system. So I put down here, I have actually this curly open and close square bracket. The next thing is I put a proper comma here. Again, I need to define my x range. Yeah. So now I have x range again, like previously I said, this x, this is y. So x will be range from -10, range from -10, 10, okay, and also a y range from -5, 5. But now, again, I have one additional determinant here. It's called t. So I'm supposed to do something with this t. So what do I do with that? So now, in order to make this thing to be something that interactive, because we have something actually super function called manipulate. You put manipulate on top. Manipulate is another function. So I have open curly square bracket. So now I have another close square bracket like this. Now I have actually additional square bracket, but the system is asking me, what do you want to manipulate about? Say, okay, I want to manipulate this determinant t. T will actually range from -20 to 20, yeah, like this. So the system know right now I'm plotting actually a 3D. I'm trying to plot a 3D. Like in this case, I'm trying to plot 3D for where x and y in this gradient. But now at the same time here, I have this little actually parameters called t here. And where I want to see when I change this parameter t, yeah, how it will affect the whole thing? Because I have little t here, yeah, little t here. I want to see actually this t is changed from 20 to 20. How does it looks like? So t sometimes quite oftenly, yeah, sometimes we to make it parametric plot, but this case is not parametric plot. We just want to see t additional variable, how it actually affect my entire actually output. So this is my entire output, yeah. So if I reach this range, drag this t, you see this entire actually animation chain accordingly. I can actually pretty much to explain the class that when t change, how rigorously the entire model will change. So I can explain it when today when I have this t as one of parameters that I'm going to sine x accordingly, what happened? Yeah, I'm going to paste that code inside the chat room so we can try out. Again, I'll give you 1 minute. You try it on your own. Yeah. Okay, I hope you all have fun and also get ideas. So again, next Tuesday, I think Desmond even share with you how actually you can explore this thing. Yeah, but not now the last thing here. If I want to show a plus x power 3, and I'll also have an x range from -10 to 10. How do I do that? Yeah, in this case here, for instance, today I want to do the x itself is a number that range from 10 to 10. Yeah, so this is something quite interesting. So in order to do that, same thing, I'm going to put like a plus x, like that, and power to 3. Yeah. So the thing here is, if you want to do this thing, Wolfram comes with something called table. Table is a way if I want to quickly actually place one of the variable like whatever x or y according to a certain range number, how does it look like? So if x is -10 to 10, yes, this is very useful when it comes to manipulations of the output. So the system will show me like this. Yeah, it immediately show me, oh, this is like you say, Peter, it's nothing much. Like, you want to do this thing, what's so fancy about that? Yeah. So the good thing is, if I can come up with like 20 output result here, right? Down here, 20 output result. That's -9 plus a minus 8, so and so forth, like not 20, 21, right? Plus including the 1, 0. So then what if I want to expand it? So I know for instance, in the Form 3, Form 4, you teach students how to expand them. So if I want to actually show this, the way how it works, I say, hey, can I do some expand here? So I put expand. The system do expansion for me for all the 21 outputs. But now, if I want to make a class actually much more fun, yeah. So this is A. Now, this is something where they call symbolic combinators. So I'm going to take a photo of my own. Let me see if I can enlarge my photo. Yeah, let me go to my Zoom, my own photo, my own photo. Let me put myself spotlight for everyone. So my huge photo coming out on my own screen. Then I'm going to put this here, mirror. Yeah, I think you see my face like that. Yeah, so I'm going to crop these pictures. Yeah, I'm going to crop myself. Okay, done. I'm going to throw this thing aside. Yeah, I put my face here. I say now, if I want to make this class slightly more interesting, I say this is A is like that. Yeah, A plus X. For some reason, this is not a very good example, but just let you know how symbolic combination works. Yeah, symbolic combination will work like that. Yeah, so pictures is too big. I mean, I run out of memory, so the system show like black color. Not supposed to be black color. It's supposed to be like, let me bring down here. Let me run one more time. Okay, let me. Okay, I don't expand this first. I run out of memory, so system just. Run out of memory. Let me take a smaller photo. Smaller photos be better. Copy image. Still run out of memory. Okay, no problem. I'll try to share with you. Let me see, make it be less. -1 to 5. I still would show up image here accordingly. It's supposed to show up image. I think, let me put it back to A first, then I put in chat room so we can try your own, and you can actually put your own pictures here. So this is some of the problem when the laptop actually having too many things open at the same time. Yeah. Okay. Now, someone is asking, lastly asking, if you're running a cloud, right? Is there actually minimum internet speed is required? The transfer of data is not that much. Yeah, it's only in the computation actually limited by the cloud capability. So the cloud version right now, I noticed that their backend computation power is possibly about like, as a local laptop, about 1.8 or 2.0 gigahertz kind of speed, about 16 gig of RAM. That kind of performance. So if you had a kind of performance on a local laptop, right, you pretty much get the same thing through cloud. But if you say, hey, I only get like, I can't get 4G, at least need 4G kind of data. So if you actually pass especially if you have actually image related things, with something less than 4G, the whole passing data will take a very long time. If you actually just want to do actually some computation with involved equation, it's not much affected. But you can try our own. Of course, there's several ways. But again, 5G, hopefully in Malaysia, will be more comprehensive next year. So things like that should be actually minimum problem. Now, the third things of this core technology I'll share with you for next 10 minutes is about Wolfram language. So now finally, we don't talk about Mathematica right now. We talk about Wolfram language. Why is that so? What does it different? What makes it stand out? Now, first thing we need to explain the big programming versus scripting. So a lot of colleges, right, these days, if they're not teaching Python, some of them are teaching C++. But for computer science, yes, you need to know the basic algorithm because Malaysia is very short of experts who develop algorithms. Because it still needs someone to develop software as a platform, you need to understand algorithm. You need to go very low level. Yeah, so you still need program. But if you somehow you apply science, you are like being taught like C++ or even Python, sometimes I find that it's not that actually, because it's certain extent that there are better ways. Yeah, so better if you in applied science and engineering, use higher actually level of programming. We call it scripting. Scripting means is there's no compiler needed. When you type, it interpret along the way. Yeah, same thing like what we are doing right now. From the moment I type it, I can execute any line I want it. You don't have to compile it. That's very little code intensive. Yeah, later I give some example. Then we find, oh, this is what it means scripting. Scripting is almost like how you write the natural language kind of things. It's very much natural language, so we call scripting. So now, understand this part. Okay, now let's look at the next thing. Let me switch back to the working environment as a slide. Okay, here we go. Now, and when you come to normal programming, when you're being taught of normal programming, usually we cannot run away when we have to deal with procedural programming. That means the entire construct of the approach is you need to write things like representing the flow logic. Yeah? The flow logic is a very low level. So it's something that, for instance, you write a lot of if then else command. Yeah, if you write a lot of while logic looping, these are traditional way of doing actually procedural programming. But in the scripting language, right, we refrain from doing so. The reason is usually doing this kind of procedural programming. Yes, like I say, you develop algorithm is useful and important. You need to do that. But if you're not computer science guy, right, you try to do the same thing in scripting language, sometimes it's a waste of your effort. Because in a computer science background, some of you are coming from computer science background. In year one, you already need to be taught about understanding complexity about something called big O notation in terms of space and computation time. So for instance, here in the year one, actually computer science, right, you are being taught, you need to actually able to use C++ or maybe Python, maybe not that much Python, but some other like lower language to write some sorting program. Yeah, sorting program in the world, they are nearly 100 over. How people sort actually things in order is surprise. Hey, Excel spreadsheet, I'm doing sorting every day. How come people are still doing that? Yes, if you want to master algorithm as a computer science, you still need to do that. So like today, I bring out this one is to tell you that if you are not people who are concerned by developing algorithm in a very low level, yeah, so Wolfram high-level scripting Wolfram will be a very important tool for you to achieve result in compressed time. Because people who need to deal with low-level programming, they have to be concerned by what will be, for instance, if same thing I'm running like writing a sorting algorithm, it will actually have different performance in terms of space and time. So the green color one means best law. We call big O1. Yeah, something like this term you don't need to care. This computer science guy will know like pink color, big O N square. That means this one, some of the sorting would take a lot of time. When this thing happens, meaning that for instance, you need to deal with multi-dimension actually array, and you need to perform computation of that. You could be surprised that if you have problem size grow, right, with different big O notation complexity, right, the time actually from, for instance, here normal way, let's say single dimension one, is 1n. If you are dealing with like 100,000 of computation, it take maybe also split second. No feeling. If you're dealing like, for instance, here, n square, yeah, that means 2 dimension. Sometimes I do 2 dimensions computations, right? You are probably running like 10,000 computations. It's going to take 0.17 minutes, which is possibly about nearly 8 or 9 seconds already. But I say nothing much at 8, 9 seconds. But can you imagine you go website, you click on that 8, 9 seconds not responding? Quite likely you're going to click a few times. And everyone's doing that, it will crash the whole system. It's like what happened to ASAP reservation last year. Yeah, this is what happened. So like other big O notation kind of complexity could be like 2 to the power n or n factorial worst case. Like you see, if you go above like 100, right? Computation is like take how many like million of years. They say, this thing will happen. I'll share with you. This is what's truly happened. And like I say, sometimes why is very important we go to a high-end computations scripting language. Like I give you one example. Yeah, this is very normal like also like Form 5. You learn about the Fibonacci number. Fibonacci number. This phenomena actually happen in real world, right? It's like 2 plus 1 become 3. Now 2 plus 3 become 5. 3 plus 5, 8. 5 plus 8, 13. And 8 plus 13, 21. This thing go up. You see like a lot of actually natural phenomena always go like this kind of circle one. It's a previous number, add this number, become next number, this number. Say, hey, this is very simple algorithm. I want to write this way. I can keep on easily come up with this thing. But the number is growing very fast, like 0, 1, 1, 2, 3, 5, 8, 13, 21, all the way like up to like 20 over terms, right? It becomes like 317,811. Yeah, but you say how difficult? It's very straightforward. But if you go to like normal algorithm, right? Now, you say, Peter, why explain like this? I try to share with you why sometimes we, like you and I, most of you, I think, engineer applied science, we don't want to actually get in the trap of actually writing program like this. This is typical actually algorithm by calculating Fibonacci number. This Fibonacci number, right, actually in a big O notation, right, is considered at to the power of n. That means n means that your number, if you want to say, give me a Fibonacci number n equal 10, this is exactly a time complexity. When this time complexity 2 or n, right, if you ask the Fibonacci number to calculate, right, up to like, for instance, give me a Fibonacci number of 100. It's going to give you like 4 times, not 10 to the power 11. You say, hey, you are Peter, you're trying to do it, not nice stuff. Like that means I try to actually blow up thing out of proportion. But it's true. If, for instance, I write actually this thing algorithm, I follow textbook. Textbook asks me to write algorithm like this. Now, in this case here, I say give me Fibonacci 35. I run this thing, right? You see, the system will go and take like maybe 10 seconds. Give me output. Give me Fibonacci number 35. Take 10 seconds. Something wrong with algorithm. Nothing wrong. This is typical textbook algorithm. It's like that. Now, see, the result haven't come out yet. So you can try. You can try this one. Let me copy and paste this one, this algorithm, into the chat room. You can try on your own. If you're using the sandbox, right? The sandbox might time out one. After you run, hey, how come keep on running? You say you're using my server free of charge. The system will time out. So it's still calculating. You see here, still running. It could be more than 10 seconds. But now, the thing is, with this Fibonacci number, there are experts out there. They find a different way to run this algorithm instead of traditional textbook way of running. For instance, if I sit down and say how to solve certain logic, for instance, just last week, someone for logistic freight forwarding, he said, I want to optimize my route. How to do that? Well, very difficult because they are software developer. They say, for years, I want to do this. I do not know how. I say this one involves mathematics. If you ask programmer to do step by step, it's not going to solve the problem. It's going to take a lot of time. But in mathematics approach, very simple. Now, it's still calculating. I don't want to calculate anymore. I just want to quick it. Say, kill it. I'm not going to wait for you. Calculate. Just came out. Now, 9, 2, 2, 6, 7, 4. So it's like take more like 20 seconds. But now, if I go back to using Fibonacci number built in by Wolfram, this one, I say Fibonacci 35. I just run it right away. Wolfram would, because now it's waking up kernel, will take a while. Otherwise, Wolfram, this one will take just a few seconds to give me a result. My memory is running low. Yes, about 5 seconds compared to just now, like it shouldn't take that long. Let me just put it. Yeah, it should come out immediately. It just come out immediately. I put 36. Yeah, come out. Just now it's just waking up the kernel. So I put 40. Yeah, immediately. See, the result is like split second compared to the one running for level. So that's why functional programming, because functional programming is really big, the complexity. So if there's a function built in already, you don't want to reinvent the wheel. So now let's take a look here. Now, finally, there's two actually main, two out of 5 important technologies, flagship technologies, actually part of the overall pictures of Wolfram has to offer. One thing is called curated knowledge base. Second one is called integrated algorithm base. You see, what does it mean knowledge base and also algorithm base? These two things I have to explain together because today in an industry 4.0 environment, you're having algorithm, but you do not have access to data. Sometimes really cut your efficiency by half. So if you have data, you do not have built-in function like Fibonacci, right? You have to recreate your own. It's going to cut your efficiency by half in some cases like that. So if you have the curated knowledge base together with integrated algorithm base together, use like adding the wings to tiger. Yeah, this year tiger year. So Chinese have old saying, this adding wings to tigers. Tiger can actually kill, and some more can fly. Or very jungle already like that. So that's how we deal with data easy. First thing, now, before I go show you an example, how to add wings to title, right? Now, there are a few things that actually this quick overview of programming. Yeah. Of course, in our actual proper programming class, we'll explain in details. But today, I just give you a quick overview. So important thing is let you know the power of symbolic computation. So in this case here, I have curly bracket. Curly bracket actually shows that this is a series of data in array. So I could have actually sub-array inside array. You see, I have a curly bracket down here. So each time I have a curly bracket, right, actually it means this is actually a set of data, or in a proper term from we call a list of data. So I have a list of data here. Also, I have a list of data externally, like this here, from here to here. And inside the data here, we will have actually all kind of actually type of parameter I can put in. I can put in numeric number as usual. I put in a variable. I can put in actually equations. I can put in a list. I could put in actually object. You see the object here, this is very interesting. This is not ordinary object. This object actually, this is toggleable. This is actually a 3D object recognized by Wolfram. So that means actually Wolfram can store a lot of symbolic data. That means today in a actually Industrial 4.0 context, right? You don't store data in the past like, oh, I only can store string, character, arcade character, things like that. But Wolfram able to store all kind of unstructured data. Now in this case here, I can even actually store color. I can store equations. I can store my pictures. So if I do this thing, the system will show, oh, this is how, or this long story, pictures, and show me the actually computed output based on my equation as an input and my picture here. So this picture is low resolution. So if I want to do this part, it's supposed to work now compared to what happened in previous example. So I say this my pictures plus actually 2 and power of 4. Okay, expand it accordingly. This graphic card is not actually functioning properly. Yeah, you can try it. It definitely will work. Just for some reason, I think my graphic card is not functioning properly. So it would not actually expand out based on my pictures. No issue. Now, there are some other things here. Let's say I want to refer to any position of my data. Now, in this curly bracket behind, I just put a double open square and close double square. So the system give me actually third position as output. So there are many ways how we can actually easily access, retrieve from certain based on index number we give it return us any value or access, or we can actually retrieve and populate the data in that position that we want to. So see if we can do this right, we can deal with data easily. Then we can easily extract the knowledge-based data from the built-in sources given by Wolfram. Also, any imported data from third-party database easily, or exchange data with certain database website very conveniently. Then we can actually do a lot of manipulation. Yes, this is not something unique by Wolfram. Any scripting language can do that, but you will see that syntax is fairly easy. So these are already made repository knowledge base. That means that it's contributed by the community and also validated by Wolfram already. So you do not be worried, oh, the data actually I download from repository, are they validated? Yes, they're validated, like places, geography, social economic data, money and finance, and some stock market performance, and physics and chemistry, earth science, and we have material science, we have even shopping products. Some of those things I even have not tried it, but when you need to use it, you will find handy. Yeah, astronomy, weather, and meteorology. Now, today I'm going to share with you some of the things that many of you might not care about weather. But what if today you want to put into really serious research? Yeah, as an example, weather can play a very important part. So for instance, in this case here, if I know I can conveniently get a lot of data from some of the actually available repository, also some from IoT, yes, we can integrate with hundreds in not thousands of devices that can directly talk with Wolfram. Wolfram had IoT project as early about 7-8 years ago. A lot of the manufacturers or devices, they can talk with Wolfram directly. It's called Wolfram Ready IoT. Yeah, but I don't need to list down those things because some equipment you might not actually really care about. But just let you know, actually, Wolfram have easy integration. They can get data from any sources. For instance, one of my classes, I'll actually teach a student how to use actually a Raspberry Pi, a very small size credit card size computer, collect data and run Wolfram for machine learning accordingly. So, and you can get data also accumulate in the cloud and also pass from for computation access or visualization easily. Now, let's make use some of those that really say, hey, how does this thing work? Yeah. Now, example down here, Wolfram has a lot of things called entity value. So entity value is say, Peter, how do you know which one entity value is for what? Yeah. Wolfram has an entire table for refer to. So one of the tables, one of the many tables is called desert. So if I want to know when it comes to desert, right, what does the Wolfram know about this? Yeah, Wolfram say, okay, if you want to ask me anything about desert, right, there are a few types of desert. There are sandy desert, stony desert, rock desert, polar desert. That means in the maybe in South Pole or North Pole, subtropical desert, cool coastal desert, cold winter desert, or some general actually classifications in desert. So you say, okay, now can you share with me among all the desert, among all repository, all those repository actually interlink one. No? You say, give me the actually database repository about desert. I say, do you have other database interlinked with desert? Say yes. I have this desert interlinked with something called area. Yeah, that means that they have this coordinate area, right? Among all desert in the world, 627. So Wolfram know altogether based on whatever human being have known currently known to mankind. We have 627 desert record in the world. Each of desert had their own GPS coordinate. So this GPS coordinate actually point to another database, which I'm not going to expand it out. So to either it's a place name or city name whatsoever. So it means which country belongs to. Things could be like that. So actually all the repository actually also interlink. So now, but today we are not here to explain this thing. We just give a quick overview about, like, say, 5 major fraction technology that make programming so much easier and efficient these days. Now, for instance, here I'm going to access a molecular repository. So this molecular repository, not everyone cares about, but the moment you see this thing can be achieved, right, then you say, oh, actually it's going to be quite easy already. So they have this one function called molecule. So you say, Peter, just want to show me an entity, so-called something called entity, right? How come suddenly you use molecule? Yeah. So in this case, entity value, right? If you key molecule, it will show a molecule also. Yeah. But today, sometimes we will have a shortcut. You say, you don't need to key entity class or so-called entity value. Instead, you just key molecule. I also know. Yeah. Wolfram also know. So you say, give me a caffeine structure or molecule. So it come out. So then I say, now, see, you already give me this molecule structure or this caffeine, C, carbon 8, hydrogen 10, nitrogen 4, oxygen 2, totally 24 atoms, 25 bonds. But for some reason, I want to be more specific. I say, can you give me an atom list? So I run it, give me an atom list. Oh, this atom list like this, yeah. But again, once I actually access the repository, now I can start perform computation, normal mathematical computation, logical computation. I say, can you tally for me? I don't want to see all those things. Tally for me. Say, okay, atom have 8 carbon. I have not 4 atoms of nitrogen, 2 atoms of oxygen, and 10 atoms of hydrogens. But you say, hey, Peter, up there already. Some more you want to show this for what? Yeah. Like here already have, but here this already show the current actually formula. But if I can change this thing, right, you see this one becomes sublist. That means I can actually treat this one as actually array of data. I can actually perform post-processing on this array data. I can do whatever I wanted. Maybe extract atom C for some other things. I can run some condition. If atom C exists in my chemical compound, I'll do this and do that. Yeah, things like that. There are many things that once you actually convert your data, there are a lot of computation analysis performed, like this example. So you can put curated actually knowledge-based and also algorithm-based data together. And a lot of the university right now is offer one semester, a semester-long class called computational thinking. Computational thinking involves algorithm development. Also, usually use all kinds of programming language they find comfortable with to actually illustrate why computational thinking actually important. But I find using Wolfram language is much easier to teach. Yeah? So it's because easy. We are not teaching computation thinking for programmers only. Because computation thinking is part like a critical thinking process. You want a student able to think how to actually solve problem, yeah, decompose it, yeah, from big to small problem, find a pattern, then actually use extraction represent, maybe equation represent it, then create algorithm. Say, hey, Peter, this natural way of solving things, not very natural. I spoke to sometimes spoke to my 12-year-old daughter. She panicked when having problems. Then I have to actually intentionally teach her. I say, when you look at these whole things, what are the things you can actually put aside and tackle and organize first? Then she followed my instruction. I say, put this thing aside as category A, B, and C, and D. Then I see what pattern you observe. And then I see, oh, certain category B has certain pattern. And which one you actually can use certain thing to describe it, or using certain kind of skill to resolve it, or resolve category B first. Then when C, B get resolved, then can you resolve D in the same way? And after all, it's a pattern you can repeat. It's called algorithm. So actually, computational thinking actually apply not just computer science, but in our daily life. But the reason I say this is sometimes people say, computation thinking, I have to actually use very low programming language. Yes and no. To me, it depends who you are teaching. So for instance, if I'm teaching someone, say, hey, I want to actually able to develop a system. And also, I myself, let's say, more statisticians or data scientists or mathematicians, I don't really care that much about programming, low level programming. I also don't want to spend time doing that. But rather, I want to immediately point to my colleague, point to the expert community where the core problem is. So I don't want to then spend time questioning my program. I just say, now this is an issue. For instance, here, if you are concerned about flood level in Auckland, yeah, I want to say the whole world is sinking, the sea level is rising. Is that happening right now in Malaysia? Especially a flood just recently happened. We are concerned the sea level. For instance, here in this case, now, if you're using, later on you open up this notebook when Desmond passed to you, you'll notice here this is something like that. It's double square bracket here. You just click one of external square bracket, you expand out. Expand out, you see the code content. I can hide the code by clicking again and click again. You can hide, open, hide, open, hide, open. So this is very handy way of doing things. Now, in this case here, I put in Kuala Tsunami, yeah, because it's close because we have this monsoon season coming from South China Sea. They're more concerned, yeah. So in this case here, we say, if I go to speak to your authority, get data or pass. Now, starting from 1980s until 2020, until today, good luck to you lah. I'm not sure how you can get data like this, but Wolfram make this thing available. We say water level, yeah, under the repository called Thai data. You can go for entity value lookup, or entity value has something called Thai data inside. I just simply put in Thai data here. Then the system asks, hey, which country are you concerned, place concerned with? You say, oh, Kuala Tsunami. It knows, no. For instance, you say, I do not want to put Kuala Tsunami here. I put something else. Could you actually, the system know? Could the system know? So for instance here, now, if I put this thing away, I say like that. If I put in something like any name like Klang, the system might not know Klang, might not know, because a Klang, actually, it doesn't know what this Klang unless it tells, oh, this is actually a city in a certain country. The system actually has something very handy. I hit Control K, it comes out with little Wolfram Kiwi here. I say, do you know something about Klang? I hit like that. Wolfram Kiwi, they are also city repository. They check among all the known city in their database, maybe 10 or 1,000 cities. Yeah, Malaysia have 200 over. Hey, begin. He said, hey, I know this Klang actually is a city, is actually assumed is a city, and is a what river Pokemon. Did I say wrongly? No. Use clown. No, it say this clown is. Do you use it clown in Malaysia? Also, another clown in France. France is a place called clown. Say which one you want to use. I say, hey, I want to use this one, clown in Malaysia. This one, left-hand side is a one actually take by default. Say, yes, correct, you're right. I say, this is one in Malaysia one. But I don't want to take Malay and clown. I go back to Kuala Lumpur, okay? So I say, give me 1980, 1st of January until today. And again, I perform visualization right away. And give me a time series date list block. And also give me histogram. So if I run this one, the system actually retrieving past 41 years data. Yeah. And 41 year data, right? I say the whole download, go to Wolfram curated data, only take less than 10 seconds. Yeah, because my computer is very heavy and running everything in the background. It might take slightly more than 10 seconds, but I'm happy because I'm able to get 21 years of data. If I get 21 year data, next thing, after I get data, I just start performing some computations accordingly. For instance, I say, I don't want the information in this case showing me in the unique matrix anymore. For instance, the time series data coming up like that. It's still running. Yeah. It showed me the actually total data point about 15,000. Yeah. 15,361, and have an output dimension of blah 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 things like resampling, interpolation. It looks something like this. You see, in the past 41 year data for 1980s, let me expand now. You have actually cyclic pattern because the monsoon actually happening every year. Every year, so the tide can go way up to, in this case, maybe a 4 meters. Yeah. It's huge, it's like 2-story high, and down to at least like 1 meter down here. So we want to see, is there actually a mathematical pattern that we can model? So we see a histogram. I skip this part. But after that, I say, no, I don't want the system to show in meters. I say, just give me a value. I don't really care which date you're talking about. I want the core value. So now it still have meter, unique year core meter. But total dimension is still 15,361. But it does not have the time, the date time anymore. So in this does not have a date time, but it still runs in sequential manner. I say very easily. I say, can you give me a partition? Partition means that amount of data here, you see, you want to do this thing in a normal program, very difficult one. So I say this C data, 21 years. I say, can you actually partition for me 365, 365, 365 in chunk? So it automate partition my C data every 365 days. So every 365 days, I say, can you give me an average value? So the system will automatically give me an average value for every 365 days. So this is my C level. So in this case, I will see in a yearly basis, what totally is my C level rising, in general speaking. So it still come out with actually meter, yeah, it 2.23, like this is 41 years ago. Now it's like 2.2237. Compare, look at this thing, also 2.2, seems like actually stable. At least we don't see like 3 meters, but we know sea level rising from the point of environmental risk. It rising 1 centimeter also very thorough already. Every year rise 1 centimeter. Let's see whether it rises 1 centimeter. So again, we need mathematical equation right now. So now we use something, auto fit mathematical equation. Fitting this model fitting is a very powerful features in Wolfram. Fit is just one. I don't put in much, like to say, tell me the fit based on these 4 terms of 1x, x squared, x power 3 in terms of x. I say, can you fit it to me? Yeah, like this. Then I want the system to show how well actually fit graphically. Of course, the system give me this equation, describe it. Yeah, I still need to do some testing now, the goodness of fit, things like that. But I do any testing. I just visually show the view. To let you know, mathematically speaking, you can actually make this thing go on. Yeah, make your actually study goes on very easily. So now if I make this thing bigger, so I can see actually, if I first look here, looks like sea level do not actually rise. It's just like at least in Toronto, it seems like for some reason it dropped. Yeah, So then we see, is this really happening? Yeah, there's many other things you can look at. But this is one way of seeing. But next thing here, when I say you could actually make use of this curated knowledge base plus algorithm base easily with all 6,000 functions built in. Now this is not illustration. With the powerful functions, right, added in every year now and then, you say you might not necessarily find it right, but every time a new release of version, I would feel benefit. I can find a better way to solve some of my current problem. I'll give you some case study later. Now, in this case, here's my picture. Yeah, because none of you turn on camera. Otherwise, if you turn on camera, we can do this thing. Yeah. So if I turn on camera here, right, this is my picture set. The system say they have a function called find faces. Wolfram have full-fledged image processing. Say, hey, image processing you also have. Yes, image processing, computer vision is one very important for AI technology these days. So if I say, hey, among these all pictures, say, could you actually automate 5 faces for me? The system will automate search, break down all the pictures here, automatically crop all the faces, yeah, and it will trim all the faces accordingly. Now, then later we can use one of AI technology that help us to find out what's their facial expressions all about. So now you find out all the faces. Now I say, can you, instead of showing me the coordinate, I want to see the photo, whether you trim according for all the world leaders, yeah, in this very interesting icon. Then after that, some are laughing, some are more serious. I say, can you tell me what the emotions are all about? So the system will have actually, we previously trained AI called facial expression. These are trained AI people put into repository. When you say a trained AI repository, what does it mean? When it comes to neural network, right, what some of you attend my class before, machine learning. Machine learning is like you train based on all the input of variables, then you predict output variables. But deep learning or neural network means that actually you can train things in multiple layers. Yeah, meaning that you do not even have to tell system what features to look for. Feature means that how do you know someone is laughing? Maybe you look at eyebrow, look at eyes, look at the mouth. But you see here in this case, I did not even tell system you look at eyebrow, look at the mouth, look at the eyes. The system might have first layer auto look up what are the features represent different emotions. Yeah. So deep learning is also, they have a lot of repository developed by Wolfram. Also have people who contributed. Is I developed this deep learning, different multiple layers of neural network. I proven it's working when I put into a repository of Wolfram. So whole world people can use it. Yeah. I do not have to tell this person laughing or this person is sad. The system ultimately actually do some categorizations accordingly or classification. So things like that. So now this same thing example. So we can use the same approach, determine if they are happy, what the gender is, how old they are. There are several things like that. So I give you one example. If we can differentiate the emotions, people also can show the emotion by the way they talk, the tone. Yeah. Also can show the emotions by the way they write. Yeah. There are many ways to show your emotions, like video show your hand gestures. So this particular case studies about 3 years ago, we did the whole project within 3 months only. And the people there had zero knowledge about Wolfram, no knowledge. So they say, hey, Peter and your team, you just come in and help us our team this thing. What they want us to solve is they have about 8 or 10 staff, medium-sized company. They're running 7 days and 10 hours every day. Yeah. Because every day what they have to do is there's one job they have to do. And the time based on the capacity, what they can do is read 600 news clip every day. English newspaper, Malay newspaper, Chinese newspaper, Tamil newspaper. What they are doing, they want to analyze with certain keyword, right? Generally, people are giving negative or positive rating. A lot of time you go to a newspaper this day, they ask you to give rating, right? Or ask you to respond. They are collecting something called sentiment analysis. But these people, right, they are not based on the website human being sentiment analysis. They're based on what people wrote. Yeah. If, for instance, today Toyota launched a new car, a lot of people talk about this car also in the newspaper, magazine, or social media. They want the people, the 8 or 10 staff reading a Toyota new model come out. What do people think? Is it negative, positive? this whole process is very important to the Toyota vendor. They want to know what people think about it. But it's very expensive, slow, subjective. If the one or staff morning gathered with a wife and come here, they look at news, the news say very good, but I'm in a bad mood. So I would say normal. Yeah. So it's also subjective. So what we did, so the boss also realized there's a problem. Cannot go on like this. He say if I want to go international, I have the need to AI built in. Now, when I use this case AI built, it means that important thing is not AI. AI you can use a lot of things to develop. But when saying using Wolfram high level scripting language, we able to develop a whole project between 3 months very successfully. We do not actually create a lot of things on our own. We just put in like building Lego block, one block at a time, all the super function Wolfram. We can achieve something like very manual based into something very fast, objective, unlimited. That means the system now can run 24/7, all new script, English, Malay, Chinese, Tamil. As long as they can OCR it into a text file, our system can run as much as they want between seconds, no limitation. If I give them 700 new script, they can run it. Give 7,000, they also can read it, all objective. The whole process become automatic. And you see 3-month project, finish it, and how much cost they save for this company. Until now, 2 years already, they're still running. So this whole thing, right, if you look at, hey, Peter, how could I achieve something like what you achieved? Community support, also very important, add into documentation. You see these entire communities, when they break down with a lot of different actually group of discussion and sharing. This is something like, this is one of the group, one of the many groups. Yeah. So you can always find actually solutions and people out there contributing. Now, cut the story short, if you say, hey, Peter, beside the video that you say Desmond work out something, what if I want to actually go on my own? Yeah, these 2 links. I can put it in the chat room. You can go there, actually try on your own. It's all free. Yeah, all this all free. You do not have to subscribe anything in order to actually go through these step-by-step videos altogether. You can go through some videos. Some of the videos only like 5 minutes. Some videos like half an hour, but organized in multiple modules depending on level of expertise, also subject or interest. So today, pretty much, I think I close everything. Now I pass the last 3 minutes time to Desmond. You have something interesting to announce, so let's stay put. Yeah. Thanks, Desmond. I pass the time to you.
Okay, thank you, Peter. My name is Desmond. So just a quick one because it's already 12. So I got 3 announcements. First one is today's handout, you can be downloaded in the link which I am going to put in the chat room. So this is the link for today's Peter's handout. So you can click just to download it. The second announcement is about the certificate of attendance. For those that attend today, you will get a free certification. So I put the link for the certification as well. So just click on the link as in the chat room, key in your full name, then you should be received the e-certificate right away. But the link will be valid for the next 5 minutes only. So do it now if possible. And the third announcement, like Peter had mentioned to you, we have a series of free training, like the link that Peter given. But we also want to let you know that what Peter has shared with you today is just a quick overview of what Wolfram Language can do for us. There are many more things you can do with Wolfram Language or Wolfram Mathematica. And for those who wish to further learning Wolfram Language with a more effective and practical way, a carefully designed course syllabus with a live instructor would be a better investment for yourself. So we are offering a series of training program, training course for academics at a very special fee. So let me show you a quick overview of what the training program we are offering right now. So these are the link I put in the chat room, and let me bring you the page for a quick overview. Just, okay. All right. So this is the page. about our Wolfram training program, or we call upskill program. We have currently a few different modules that can suit for different user. So we have module A, B, C, D, like for lecturing, presenting, for AI machine learning, or if you are interested with data analytics, graph or networks or programming or certification. They are carefully planned syllabus for those are interested. If you further scroll down, as I mentioned, we are offering this for academics only. So some of the modules are started with only 100 ringgit for the few sections for each module. If you further scroll down at module A, we are running 4 sections from 24th of February, 25th, 3rd of March, 4th of March on the 10 a.m. Each section will be around 1.5 hours for this module A. And also module B is more intensive and specialized in machine learning. We have 5 sections, and each section is running from 2 p.m. to 6 p.m., 4 hours per section, totally 20 hours. It's only 250 per pax. And also some other modules C, D, I leave it for you to explore. But you can see our schedule through here as well. There's a program calendar. If you further click in this program calendar, you can see all the scheduled time we have been planning for the program. We have run this program for at least 3 or 4 times in the last year. So for this year, this is the first series, first cohort. So for February, you can see on the module A, if you further click in, you show the time, the start time and end time. This for module A in February. In March, we have module B, module C, and April, we have module D, module E as well, before the start of the Hari Raya. So those are some date and time you probably want to check, drop down. So probably check your schedule. If you are interested, you may sign here today. The pricing we are offering is the same as last year, but probably next month onwards, you have some adjustment on the price. So if you are interested, sign now. And for those that are in today, we'll give you a special promo as well. If you sign in today, you will get extra 10% from 10% off from what we have put in the list price. So if it's 100 ringgit, you get 10 ringgit off. So the promo code would be 10 off. Let me put in the chat room as well. So those are the promo code OFF10A. Okay, if you put this in promo code in the registration form, you get 10% off. And also, if your friends or colleague or anyone that sign up with your name as a referral, you will get extra 10% cash back. Okay, so those are the special promo we're running for today. I got a question from Janice Wong. May I know 100 per pax is for 1-day training? Is for the module. So the module, if they got 4 sections, this 100 per pax is for 4 sections. So each section is only 25 ringgit. And each section probably is running for 1.5 to 2 hours. And for the module B, each section is for all hours. Then total 20 hours, it costs only 250. 250, if sign up today, you got 25 ringgit off, so it's only 225. If you got 2 friends sign up, you got extra 50 ringgit cash rebate. So you end up, you only pay 175 for the whole sections. Such a good deal, right? Okay, I don't want to hold you up for long. If you have any question, you probably can put in the chat room. We are more happy to help on you. Okay, thank you and bye-bye. And see you on next Tuesday and Thursday for those that sign up for our next 2 free sections. And please come again. Thank you.
Bless you all guys again. Okay, take care.